Hello everybody, welcome to Unit 7. We're going to be covering sediments and sedimentary rocks. So we're talking about these beauties right here. I've showed this slide already, so we'll not spend too much time on this one. All of these are sedimentary despite how different they look and different processes are going along with them. We have sedimentary rocks over here and this over here, sediments. Section 1, we're going to talk about breaking down rocks. So before you get sedimentary rocks, we need that first thing, which is sediment. As far as our larger rock cycle goes, mostly in this lecture, we're going to be talking about what's happening up here. So when we have a mountain range, these things are high and exposed to the elements, they weather and produce sediment as a result. So what is the difference between weathering and erosion? Are these different? What is the difference? Weathering is the breakdown of the rock. Transport of the rock is erosion, though. So weathering can be chemical or physical. We'll talk about this more in a bit. And the transport can be in any variety of ways. It can fall down a hill, gravity, it can be wind blown for small particles, it can be taken up in a river, or it can be moved with ice, with glaciers. These are not exactly the same. You might remember by thinking that weathering is like the hammer, breaking the rock up, and erosion is the truck which hauls it away. I also find this visual to be helpful here. Weathering breaks the rock down, and erosion moves it to another place. There are many different types of weathering. We're going to talk about two, really. First of all, mechanical weathering. So this is the breakdown of rock into solid fragments by physical processes. So even just physically, imagine hitting a rock with a hammer, that is mechanical weathering. We are not changing the chemical composition of the rock. We're going to talk about four types of this. We have exfoliation or sheet jointing, frost wedging, root wedging, and salt wedging. So take a moment. She seems to be enjoying, what is this? An exfoliation process where she is put something on her face and now later she is peeling back layers of skin. Something very similar happens with rocks. Notice here that there are these sheets, these little layers which are being weathered, being broken down as a result of, in this case most likely, exposure to the sun and slightly higher temperatures in the day, which causes the rock to expand, and then colder temperatures during the night, which cause it to contract. You do this over and over again for many days, and what you end up with is a pattern like this, where it is coming off the rock in sheets. You might also see something like this. So imagine you take a can of Coke, and you want to cool it down really quickly. You just bought it from the store, it's not cold. You throw it in the freezer, you walk away, get caught up with something else, whatever it is you do, and you come back and it looks like this. Well, what happened here? What happened is that the ice takes up more space, more volume than the water. So once it freezes, once it gets that cold, it actually starts to expand all the material in there. And so it blows up the can. Actually, if you leave it long enough, it can blow up completely. And we see something similar with rocks. So we have a rock with a crack in it that gets filled with water, result of rain. And now once it freezes, it pushes outward extremely hard and breaks the rock open. You multiply this again many, many days, many, many times it's happening, and you might get something like this. So water trapped in there, freezes, and expands, breaking the rock. You can also have root wedging. So here we have a tree whose roots are slowly breaking apart the rocks on which the tree stands. Again, very slow process over time, but you can break rocks using root wedging. You can also have something called salt wedging. So this is kind of similar to what we talked about with frost wedging. You have salty water, which is deposited inside cracks in the rock. Water evaporates and salt crystals are left behind. And as those crystals form, they push outward on the rock and break it. And it leaves you with this sort of terrifying pattern like this, or maybe not. It actually looks very, very vesicular, though keep in mind this is a different process than what we see with igneous rocks. Chemical weathering is a different sort of weathering because here we're actually changing the rock itself. We're changing the chemical makeup, changing what it exactly is in terms of material. So here we're going to talk about oxidation, hydrolysis, and solution. First, oxidation, you should always think of rust. So oxygen in the air or water is very, very reactive. It is a very reactive thing. Whenever it reacts with what is on the surface of the rock, sometimes it will form literal rust or other sort of oxidized products on the surface of the rock. And you notice this side more than likely was broken off by whoever this person was, just to show what a fresh face would look like. So we have after oxidation and before oxidation over here. And this one is very much signaled. Anybody who saw this rock could sort of tell here that there's a change in color. This is maybe rust on the left side here. You can also have hydrolysis. So what we're talking about here is the breakdown of rock due to chemical reactions from water. So short thing for this one. You imagine a rock, you put it in water, and as everybody knows, as soon as you put rock into water, it starts to bubble and foam. So over time, slowly, many days or years, the water will slowly change what is in the rock and make it more susceptible to other weathering. And it actually a lot of times will produce a pattern like this where you have these smooth, sort of strangely rounded rocks. It's not always a mechanical process doing it. Sometimes there is a help from hydrolysis. This is, of course, more common, and what we're looking at here looks like granitic rocks. So, solution. This is a case of removal of rock by acid rainwater. And we're not talking about completely acid rain with this one. We're talking about partially acidic, just very slightly acidic rainwater. What happens is that when you have water in the atmosphere coming down as rain, it reacts with carbon dioxide and forms just a little bit of carbonic acid, a little bit of acid. It becomes just very slightly acidic, but it is enough to do something like this. So this is, well, likely a limestone statue here, which we have seen exposed to rain many times. Over time, we can see that it has dissolved, it has etched and taken little pieces of the statue away. See this? Statues, sometimes gravestones, which are made of limestone, around the surface, taking these things off. Finally, you can also see this sometimes with cave systems. So you have water, which rains down, and then it trickles below the surface and starts to dissolve what is down there and forms cave systems. So if you have a giant bed of limestone on the ground, it's exposed to rain continuously, it'll start to form these caverns as the water etches through the surface of the thing and takes material away. You can actually build huge cave systems using this process. So, what affects weathering? What are our factors here? First things first, surface area. More rock exposed means more weathering. Time. More time is going to mean more weathering. Rock composition, which is complicated, but know that this is a factor. And finally, climate, which is very important here. We're talking about, more than anything else, temperature, hot or cold, and the rainfall, dry or not dry. Specifically, this is what we're going to look at in a lot of places as our main factor in weathering overall for a certain place. There's two primary ways that it's going to affect the rock. First of all, we're going to look at chemical weathering, which is generally more prevalent in warmer, wetter tropical climates. You have more exposure to rain specifically, so we're going to have more chemical weather as a result of being exposed to water. What we're not going to get is what? What are we not going to get? So we're not going to get as much of the frost wedging, the mechanical weathering, which is much more prevalent in places which are cold and dry. So this graph here is showing a lot of information, showing different realms of mechanical or chemical weathering based on two factors to talk about. Temperature, we have amount of precipitation, annual rainfall, wet or dry. So hot and wet is down here, lower left, and we have cold and dry up here in the upper right. And you might be wondering why all of this is just grayed out over here. Is this half finished? Am I getting what I paid for? You might take a minute and try to figure out why there is nothing over here. So the reason why there is nothing over here is because nothing on Earth would fall into this region of the graph in terms of being extremely cold, but also having a huge amount of annual rainfall. You might have heard that Antarctica is the biggest desert in the world. This is what we're seeing on the graph here. Places which are extreme in terms of cold tend to be very dry for the most part. Now we're going to look over here. Notice we have these little red dots, or yellow dots or blue dots here, which show, based on the color, where they would line up in this graph. We also have a series of black dots here, which we are going to figure out, starting with the one up here, Greenland. So where on this graph would you expect Greenland to fit? Expect it to be maybe a little colder and also maybe a little drier. We look at some of its friends here, northern Alaska and northern Canada, which you might expect to be similar to Greenland. Notice that these are falling in the strong mechanical region here, this sort of blue. So we'd expect Greenland to either be in this region or very, very close to it with one of the neighbors. And if we look, we see that Greenland actually does fall right here with the strong mechanical region of the graph. Now, we'll move down here. This is supposed to be Seattle. Seattle here in the US. Expect this is a pretty humid place. If you know anything about Seattle, you will know that it's always raining there. Not always hard, but there's always going to be some rain. And now you wonder, is this a hot or cold place? Now, compared to Arizona, compared to Phoenix specifically, it probably seems like it would be extremely cold, somewhere up here, but remember, these are in C. So mean annual temperature of, let's say, 5 or 10 degrees C, right? Remember, this one is 32 Fahrenheit, so maybe a little bit warmer than that. And we would maybe expect it to be moderately wet as far as rainfall goes. We can also cheat and look at its neighbor up here. So I would expect it to be either right here in the middle, moderately wet, moderate temperatures, or maybe down here. But I would maybe peg it as like right here on this graph. Okay. And it looks like moderate chemicals. So it's maybe even a little bit warmer on this than I thought. Moving on, we have Denver, Colorado. So Denver, whether or not you've been there, you should know it's a little bit dry. It's, you don't have giant trees necessarily. There's a lot of grasslands. Again, we're not talking about up in the mountains. We're talking about lower in the city itself. I would expect it to be a little bit colder than maybe what we're getting. We also look at its neighbors here. So I would very strongly expect it to be either this moderate chemical with frost action or moderate chemical. I would maybe peg Denver as being about right here. Okay, moderate chemical with frost action. Moving on, we have Phoenix. I would expect everybody to at least have a pretty good idea on this one. Phoenix is pretty hot and pretty dry. Let's see where Phoenix is. As we expect, very, very slight weathering, mainly by wind. Phoenix, you imagine, you see something like the White Tank Mountains or the Estrella Mountains. They have these sort of jagged faces on them, very, very rough shapes on the mountains. It's because there's not a lot of these other forces, either frost wedging or water, rain, which might break these down roundabout in any way. Instead, mostly weather action, which is going to happen in Phoenix, is going to be as a result of wind and wind action. Moving on, Florida. So, what do we know about Florida? We know it's hot, we know it's humid. I would pretty squarely expect this one to land about right here. It could possibly be closer to here if the rainfall is not, which I think, but I would pretty much expect this to land here in the red zone. And that's what we have. Think Florida, you think strong chemical. And what about down here in Brazil? Down here in the Brazilian rainforest. Well, you see its neighbor here in Central America. You also see something that's a little closer to, I believe, the Peruvian desert here. But where is Brazil going to be? I would also imagine this to be pretty hot and pretty humid, and expect this to land right about here. That's what we get. Section 2, we're going to talk about the sediments themselves.